Today we are going to continue about the data categorization. So in the previous lecture, we finished some part, because we have a two part of the lecture two, So this is the, maybe around 10 more slides. I need to explain here. Okay, so about the multidimensional data modeling, if you remember from the previous lecture, you have finished until the NOIR, NOIR, right? Nominal, interval, nominal, ordinal, interval, and ratio. So now we are going to learn about the data cube, for multidimensional modeling. All right. Data cube, for multidimensional modeling, because previously we learned two dimension, for. So if you remember that the difference between two dimension and multi-dimension means that more than 2D. If two dimension is the data is only like this, right? So only X, Y, for example, only two coordinate. If more than two, let's say 3 dimension, then we put another one. So 3 coordinates, X, for example, Y, and Z here. So in multidimensional data modeling means we are going to learn this part. This part. This is only the normal data, which with one, let's say, column and row. Right. So then this one, so we have some layer, so we can construct for multi-dimension of data. All right, so the concept of data cube here, we can see. So multi-dimensional data model views data in the form of cube. So you know cube, right? So this square, and you want to know the cube, So this is the cube. So it's construct looks like the cube, the data. For squares actually only for 2D, right? 2-dimension data. This is, we can say, 2-dimension, and this one for 3-dimension, at all multi-dimension. Right? So the multi-dimension data model, views data in the form of cube. This one, right? Because this one is 2D. And the data cube is characterized with two things. The first one that we have to see is dimension. So the perspective or the entities to which an organization want to keep record, this one. And the second one is fact, the actual values in the record. So this is the example, an example of the data cube, like rainfall data for meteorological, meteorological department here. So time, and location. So in time there is a year, for example, season, month, week, day, hour, even hour. Then we can count as the time. And location can say country, region, state, and so on. So if we construct the data, so this is for the 2D view, 2-dimension view. So we can say region, northeast, so month and year. This is only 2-dimension, So this is, for example, Y, this is X, right? So horizontal line is X and vertical line is Y. So in this 2D representation, the rainfall yeah, for Northeast region are shown in here. Yeah, here. So Northeast region. And with respect to different months, yeah. So for a period of a year, this is 1 year. Yeah, from January, yeah, to December, right? And then if 3D view, 3-dimension view of rainfall data, so we can construct here. So suppose we want to represent the data according to times, yeah, based on year or month, yeah, as well as region of a country, east, west, north, northeast, yeah, and so on. So a 2D view of 3D rainfall data. This is based on 2D. Yeah, I mean actually for 3D, but we construct only 2D. So there is the east, west, northeast, right? Because we spread it one by one based on the region. Yeah, so east, west, northeast, and the variable, yeah, is the same. Yeah, year and the month. Yeah, so January, the month for 1 year. Yeah, from January to December, and we just follow, yeah, from the first one. I mean the first region, for example, is east, yeah, and then west, and then northeast. Right, so exactly the same, only the region is different. So we can say this one 2-dimension, but actually from 3D. Then how to construct the 3D? Yeah, this one, because so this is the region. Yeah, the data is actually the variable is the same, right? So because of year and month only. So we use month January to December because of 1 year. And year we start, for example, here from 2005 to 2010. Yeah, 2005 to 2010. So all the same, only the region different. So we can construct here, yeah, year same, yeah, because of from 2005, yeah, to 2010, 6, 7, 8, 9, 10, yeah, until 10. So 5, 6, 7, 8, 9, 10, let's say, yeah. And then month, yeah, from January, yeah, to until 1 year, yeah, December, let's say, right? So then we have some region here. So that's why we can construct like a cube. Yeah, because of this is, for example, is region here, the first one. And then the second one is, for example, west region. Yeah, this one, northeast region, yeah, southeast region, and so on. Yeah, so we construct, yeah, each layer. Yeah, so then we can see, we can say this one is a 3D view, a 3-dimension view of the rainfall data, because we put all the region, yeah, together, since the year and the month is the same. So then we put together here, then becoming 3D view, or we can say the 3D view of the rainfall data. So it's construct the cube like this. Yeah, if one region only, then we see the 2-dimension, right? Because so we put many region here, so then, yeah, it looks like 3-dimension. Yeah, so this is the region. Yeah, so construct 3D view. All right, so that one for one country. So what happened if we put many countries? So we have many cubes here. So for example, India, yeah, China, Russia, Pakistan. Yeah, so we put many countries, then construct for each country. We have a cube. Yeah, we have a 3-dimension view. Yeah, so even, yeah, because of the data, yeah, I mean the nature of the data is the same. Yeah, only the value for each, yeah, may be different. Yeah, right. So in the area, yeah, maybe Southeast Asia, almost the same. Yeah, like Brunei, Malaysia, Indonesia, because we are exactly, especially Sabah, Sarawak, Brunei, and Borneo, yeah, Kalimantan. Yeah, maybe the same for the rainfall, yeah, almost the same, the data. Yeah, only maybe a little bit, yes, bit different, not so different, because on the same island and same area, right? But for Russia and India or Pakistan, maybe different. Saudi Arabia, even we don't have a rainfall, yeah, maybe only less than 10 times a year, yeah, for rainfall. So that is the 3D view. Yeah. So what is that, the cube representation of rainfall data of the entire world? Yeah, we put this is some countries, and then how about for entire world? So it will construct like this. Yeah. So consists of many cube, then again construct a big cube for this. Right? Because of all over the world, maybe we have more than 160 countries. So then we put this one, yeah, and construct a big cube based on each cube from each country. Yeah, so this one, let's say one country, yeah, one country, another country, another country, another country, another country, different country, yeah, different country. So then construct a big cube based on the rainfall data, yeah, for each country. Right. So these are the cube segregation. Yeah, so we can make a slice for each, and then this cuboid, yeah, for was it the one slice, yeah, because of this actually for one cube represent the was it the rainfall data for one country. Yeah, so another challenging thing is how document, for example, here text can be represented. Yeah, so of course we have to see to find, yeah, the data inside. What kind of data inside? This is a text, for example. So then how we can represent this kind of text, and then how image can be represented. Yeah, so the data from the image. Yeah, so in image processing we can use like for image representation we can use like a matrix, yeah, matrices or matrix. So we can construct. Yeah, it depends on the kind of kind of image. If the image is full colors, of course, will be completely different with the grayscale, yeah, or with only monochrome, yeah, or black and white. So that is the image, yeah, how to represent the image. And how about the video? How the video can be represented? Yeah, so video actually consists of many images, many images. So we take image and then put in the sequence. So we can say as the motion picture. Yeah, actually from the picture of or image. So, but then it consists of 1,000 or million pictures. So that's why we can construct, or we can develop the video, yeah, based on a picture or image, yeah, some images. So that is the thing. Yeah, so video and image almost the same. Only this one, of course, the size, yeah, or the number of pictures. That's why video will be the much higher in terms of the memory or file size, capacity. Yeah, for the file size will be very much higher than image. Yeah, so image maybe only even byte or kilobyte. Yeah, so let's say 10 kilobyte, 15 kilobytes, or 100 kilobytes. But video, yeah, we can say video in gigabyte. Yeah, maybe 1 giga or even more. Yeah, because of it consists of many images. And then how about the streaming data? Yeah, streaming data. Yeah, this one, for example, from Earth satellite. Yeah. So then for further reading, so you can read this kind of book, yeah, Data Mining Concept and Techniques, but actually this one for advanced one, yeah, for the data analytic, but more advanced, yeah. So this one we learn only the basic one, the basic part. Okay, finish for the topic 2, yeah, from the data categorization, yeah, data representation. So any comment for this lecture? Yeah, so you have done also the tutorial, so you can hopefully you can get a more knowledge in terms of the concept, yeah, theoretical concept of the data representation or categorization. And so then you can classify the data based on the category, whether this is a nominal, ordinal, interval, or ratio. And then the nature of the data, because of this part is very important before we proceed for the next analytic, data analytic, more complex and details. All right. Any comment or any question?
So far, no, sir.
No? Right, clear, yeah? All right, so still a basic concept. Okay. So finish the data category or categorization, and we continue with the next topic, yeah, about descriptive analytic, yeah, or descriptive statistic. So this one, after we understood the concept, yeah, the theoretical part of the data, yeah, the category, then now we go for the analytic. Yeah, we use some mathematical formula, yeah, to solve the problems here. All right. So I hope you have Excel, Microsoft Excel, at least in your computer, right? Do you have a Microsoft Excel in your computer?
Yes,
Hopefully,
sir.
yeah, for sure, yeah, because of you are computing students, so then I suppose you have basic, for the necessary software, for all necessary software for computing process or study. So can you see the slide now?
Yes.
Okay. So descriptive analytic, or we can say also the descriptive statistic, because of we learn more about the analytic, which is also part of the statistic. Okay, so in this part, maybe we start to use Excel, for some basic things, and then I will introduce also. If there is a very good book, so then you can just use this book as a catalog. So actually, when you find or you want to solve the calculation, or analytic using Excel, so then you just find from this catalog, then you can apply or just see the instruction or syntax or the how to perform this analytical process. All right. So we can use also SPSS if you want, SPSS. But this SPSS you need to install with the different application, So you need to download, There is actually, if you have in UTB, the software, it is better, because it should be, like a license. Yeah? We should have the license for this software. But with Excel, I think most of you have installed already, because of by default. Yeah, usually when you buy the computer, then it will be with the operating system and the basic program, or basic software like Microsoft Office. So then you can operate or use this for many work, yes, based on the application or the project and so on. Right. Okay, so what we are going to learn in this topic. At the end of this lesson, or this learning process, students should be able to create a report summary, especially for statistic, population and samples, and to create the report for the frequency distribution, also to generate the histogram of the quantitative data. Because of this kind of data should be quantitative, in order to we can to be analyzed, or we can analyze and then calculate the measures of the central tendencies, and evaluate the characteristic, and also calculate the measures of dispersion. So get the report, and generate the diagram. In this case is a histogram. Calculation for measures of central tendencies and measures of dispersion. And then, so we can say this one is actually the illustration of descriptive analytic. So the goal to get a general sense of the data. And then for this purpose, so we have to identify the variables or attributes. We can say variables or attributes for the data. So like a year and also the size, and as mentioned in the previous one, the previous lecture, about the data cube. We have rainfall data. So there is a year and month, for example, for 1 year, and for each month, for the data. So that is we can say the attributes or variable, and then assess or evaluate them. And then we have to calculate the summary statistic, like means, medians, proportion, mode, standard deviation, variance. So all these statistic we will learn in this lesson. And then generate chart or visualization, like histogram, pie chart, bar chart, and so on. And should always look at every variable, So we learn, because of based on the variable, we can see, observe the nature of the data. And then may need to collect more instances of data, from the data sources. So maybe we need to collect, scrap the data from the resources, and after that we put for the analytic, for descriptive analytic. And especially for this descriptive analytic are useful in early stage of data analytic, or to detect the outliers or the extreme values, and then test some assumption. So do you know about outliers? What does mean? Any of you? Can you just little bit or briefly explain or describe What is mean outlier? Any of you? Did you learn about the statistic? Is there any statistic course here in your program? Or mathematics maybe? Mathematics for computing, for example. Is there any course related to mathematics or statistics? No? No mathematics part? Supposed to be, I mean, supposed to, you have a mathematics, at least like fundamental or mathematics for computing, for example. Because of computing, like data analytics, especially, or even networking. So we have to know about the basic fundamental of mathematics, especially for computing. Because in network, yeah, we will learn about the cryptography, security. So there will be some calculation also about the cryptography. Yeah. And then for multimedia even, yeah, so we learn about the image, yeah, how to construct the image, and then there will be the operation, mathematical operation as well. Right. So basically outlier is the value that not on the common value, yeah. So we have a certain statistic common value, but then this one is outside of the graph, yeah, or the norm distribution, we can say. Yeah, we can say if we have many data, yeah, we construct many data here, and we can say this one as the, oh sorry, always appear the horizontal line like it. I don't know. We have this data. So we construct this data and then build the norm distribution or normal distribution. Right? But there is maybe one or two data outside of this, yeah, outside of this norm. For example, is this normal distribution. So we can say this one extreme value or extreme values or outliers. Yeah, if we have many, then we say outliers. Because of this is these are uncommon data outside of the normal, right? So inside of the normal, we can say the normal distribution, yeah. But outside, so sometimes there are some data actually outside, yeah, because of that from the population, normal population. So we can by nature, yeah, we can avoid that. So depends on us how to calculate or analyze this data. You want to include this all, because in the population always there is some outlier, not the common one, right? Yeah, like the richest people in the world, for example, in the world is we can say Bill Gates, or maybe what's it, Mark Zuckerberg, or Elon Musk. Yeah. So those people are outlier. Yeah, we cannot include those people to the statistic for the calculation actually, because it will make a bias, right? So those are outlier. Yeah, if we want to get the the normal calculation, yeah, in terms of the acceptable result or rate, so we have to exclude. But in this way, we learn about the statistic. Later on, I will explain you about what is the difference between the median, between the mean, between the mode, and what the effect of the outlier to this statistic. All right, statistic or the descriptive analytic. So test some assumption, for normal distribution or skewed, for the slope, So these are the use of the data or descriptive analytic. Okay, so the next one is about the function or the use of the descriptive and statistics actually to report the summary description on population and samples. Yeah. So this is the population. There are many inside of the population, and if we take some part from the population, then we say this one is sample, right? Okay, so for example, in this class, this is the class of the fundamental of data analytic course or module. So there are about how many? 46 students here, participant. So that is population, we can say, right? 46 student. And then when I take, for example, here Akil, and Wazif, so these two student will be the sample, for example. So sample, if we take some student, like here, for example, I take here CR only, so Akil, Wasif, and Iqbal. So then we can say these three as a sample, or any student in this class, so we take maybe let's say Khairil, Kamarul, Lee. So then we can say these three students are the sample from the population out of 46 here. Okay, so this is the difference between population and the sample, right? So sample of this class, this module. For the UTB student, if we take, for example, I'm not sure how many students, let's say in UTB student population is 3,000, for example, and then we take 10% from the population. So, or maybe 1%. So from 3,000, we get 30 students, let's say from this class. So we can say this class is sample, sample from the population of UTB student. Right, so summary description of measurements or variable taken about the set of items, speed up and simplify the comprehension of groups characteristic, and it can help to identify especially the normalization or the pre-processing issues for the data cleaning. So this is an illustration of the descriptive statistics. So there is two classes or two groups, and they have their members do the IQ test, and which group has higher overall IQ here. So for example, this is the class A, class A, and then the second one is class B. So class A consists of 13 students. Class B also the same, 13 students. So they did IQ test for this all student, 13 student from class A and 13 student from class B. So these are the result, from class A, the IQ test result here, 102, 102, 128, 131, 98, 140, 93, 110, this all until 13, right? 89, 106, 119, 97 for class A, 13 students. And for class B, so they got the result, this one, 127, 131, 96, 80, 93, 120, 109, 62, 103, 111, 109, 87, and 105. So each individual may be different, right? So as you can see here, yeah, it's individual, got a different result. And if we try to understand a group by remembering the qualities of each member, become overwhelmed, yeah, and fail to understand the group. Yeah, if we try to remember one by one, yeah, of course it will be very hard. Yeah, this is only 13 students for 2 classes. What happened if here, even in this class, we have 45 more students, right? 46 students. So then, yeah, overwhelmed. Yeah, we will fail to understand. Yeah, if we don't do any descriptive statistic, yeah, or analytical thing. Yeah. So this example, yeah, actually representing the descriptive statistic. So this is the illustration. Later we will conduct also the calculation for each, by understanding for terminology of statistic, descriptive statistic, yeah, for the purpose of analytic. All right. So which group is overall smarter now? So based on this, yeah, we try to see, yeah. So if there is a question, yeah, in overall, yeah, which group is smarter, yeah, class A or class B, yeah, based on the given data here, the given data here, class A with this data, yeah, 13 students. These are the result of IQ test, yeah, for class A, and these are for class B, the result of IQ test. So based on the given data, so how we know the smarter, yeah, I mean in average, the smarter student, yeah, in class B or class in overall, yeah, class B or class A, yeah, which one is smarter, yeah, in average. So how to calculate that? So we have to, yeah, of course, to count the average, right? Isn't it? Because we want to compare the class, yeah, not the student, but the total, yeah, the class, the IQ for the one class we want to compare, yeah, between class A and class B. Yeah, so in order to compare, yeah, we cannot compare one by one because of the question is the class, which class is much smarter, yeah, yeah, class A or class B. So we have to make, to perform the calculation here. So find the average, right? The average of the class. So based on the average, then after that we can compare, right? So here, class A, how to count the average? Do you know the average of class A, for example? How to count this? Any of you?
You
Yes.
plus all the answers and then divide by 13.
Right. Yes. Great. So you just add this all data, yeah, from class A, yeah. So 102 plus 128 plus 131 plus 98 plus 140, yeah, yeah, plus 190, 10, 110, yeah, and until 97, yeah, plus all and divided by the number of the student, yeah, yeah. And then the second one also the same thing, right? So try to calculate here. You have a computer or calculator, then just try this one. Class A average, how much the average of the class A? So just plus 102 until 97 and divided by 13. Can you get the result? Any of you, please? Please try this one because this kind of calculation maybe will appear in test or in exam, yeah. So you please to try to exercise or to perform some practical thing, yeah. Otherwise, then maybe you will forget. If you learn and you are doing also, then maybe it will help you, yeah, to remember. So for class A, what is the average of class A? Can you count, please? If you have a mobile phone, you can count by using mobile phone. If you have a calculator in your laptop, you can also use the calculator in your laptop. If you have standalone calculator, so it is much better. So just the function for calculate. Please. For class A, what is the average? Kamarul is here?
Yes, sir.
Yeah, please, Kamarul.
110, sir.
110? Yeah, maybe there is
110.5.
yes. So please, maybe until 2 digit behind the point.
110.53.
53, okay. Yes, around. Okay, this is for class A, right?
Yes.
Okay. And then Khairil, try for class B. Or Nadira, maybe. Just class B, try class B.
110.23.
110.23.
Yeah.
Okay. Yeah, so you just sum this all the data, right? From 127 until 105. Yeah, plus all this data and then divided by 13, the number of students. Yes, this round. So based on this data, which one is smarter? Yeah, just plus minus because of the number here. Yeah, the same 110. Yeah, so only almost the same, right? So this is the result. Yeah. Okay. So yeah, you at least you got this idea. Yeah, how to, because this is the basic thing, very basic, the average. Yeah. The average also included in the descriptive statistic here. All right. Yeah, good. Yeah, so with the summary of the descriptive statistics, it is much easier to answer the question, right? So when we got this one average, yeah, for the class A, yeah, and the class B, then after that we can answer, yeah, which group is overall yeah, smarter than, yeah, smarter. I mean, in comparison between class A and class B. So then based on this, then we can answer, even though the number is almost the same, yeah, the value, but you can see still, yeah, 2 digit behind 110. There is a little bit, yeah, difference. So that's why it is much easier to answer the question, right? So understand so far?
Yes, sir.
Yeah, all right. So because this is very important, yeah, the descriptive statistics. So we start with average. Right. So you can use this one also with Excel. Yeah. So you have an Excel. Do you familiar with Excel?
No, sir.
No.
Not really, sir. Not really.
Yeah. With Excel, in Excel there is the average. Yeah. How to find the average? Actually, the calculation. I will see. So now you try here. Now open the Excel. Yeah, open the Excel. Then you make a 2 column in Excel. So I will show you at the beginning. So try to open the Excel right now. Your Excel, your computer. Yeah. So yeah, I'm not sure. Maybe you can make 2 windows. Yeah, in your computer laptop. Yeah, and then one for Excel and another one for the class. Yeah, and then create, I will show you, yeah, the creation. Can you see the Excel, yeah, from my side in here in the screen?
Yes, sir.
Can you see?
Yes.
Okay, so you just provide the two column here. Yeah, start from class A. Yeah, maybe not necessary you put class A IQ here on the top. Yeah, you just put the number to make it easy. Yeah, because our class A IQ will not be count. Yeah, but if you are familiar, then it is easier to do this one. All right, so you provide this one. Yeah, try to write, yeah, two column, yeah, based on the IQ. Yeah, there is a two classes, all right, on the slide, as I mentioned. Class A IQ, yeah, with the data IQ data, there is a 13. Yeah, here 13. Yeah, one. Can you see the cursor here? I saw 102 in the screen. Can you see on the screen?
Yes, sir.
Can you see my cursor moves?
You mean
Yes,
the
sir.
green ones? Yes, sir.
Yes, sir. Yes, sir. It's moving.
Okay. All right, good. Yeah, good. So then easy to explain here. So yeah, we have 13 data, yeah, for each class, right? Class A and class B. So we just write down, yeah. So this is 1, 2, yeah, 102 until 97 from the class A. So just write down, yeah, 1, 2, 3, 4, 5, so until 13, right? 97, the last one. And then the class B also the same. Yeah, start from, just put on the square, yeah, based on the data given, yeah, on the slide. So you write down here, yeah, 127, 131, 96, 80, 93, 120, 109, 162, 60, 103, yeah, 111, yeah, 109, 87, and 105. Right, so you got two column, right, based on the class. So class A, the IQ data given in the left side here, left column, at the first column, and class B IQ for the left column, right? So I'm not sure we can see the formulas or not here. Okay, so there is a formulas, yeah. So actually, if you want to calculate manually, you can, yeah. So this one, you just sum this one, yeah, here, and you will get the this is the formula. There is on the top. Do you see my cursor moving? It's moving.
Yes, sir.
Okay.
Yes, sir.
Yes,
There
sir.
is formula. There is a data, right? Formula. So then you just check the formulas here. Yeah. So yeah. So then, for example, this is sum. Yeah. You want to see the average, all right? Yeah. So just click the average. Yeah. See the bottom of the number here, the bottom of the data here. There is the average. Can you see?
Yes, sir.
All right, good. Yeah, so I give this one the highlight, yeah. Yeah, yellow highlight. So then please do for the second one with the same formulas here. Can you see? Can you do?
Yes.
Yeah, so sum, yeah, with average. Yeah, you just select the average, yeah, and you will get another one, right? Easy, right? Easy or difficult? You can do try here, try and error. Yeah, if this is not the right one, you just check different thing. So average, numbers, the max, mean, yeah, it's all are the statistic descriptive. Yes, or descriptive analytic. Yeah. So even you want to see, okay, the max, yeah, this one, and this data, Yeah, which one max? So you use formulas, yeah, and under the sum, yeah, you can see the max here. So max is the highest, right? So 140, the highest IQ here in the class. And then from the max, okay, so you want to see the min, yeah, minimum. Yeah, so just back to the sum here and then find the minimum one. So you get 89. 89 is the minimum. This is still easy because of only 13 data, right? From 102 until 97. What will happen with 100 or 1000 data? So yeah, it is headache, yeah, if you perform this kind of calculation manually. But using the Excel, all the things can be done, yeah, easily. So for the second one, for example, here, so then you use again the formulas. Yeah, then we find, okay, find the max, the same thing. The max is maximum value here, IQ, and from the IQ data is 162. And then again, we block this, yeah, because we want to see the coverage, yeah. So 13 data, then again back to the formulas, yeah, then find auto sum here, find the minimum. Then you got the 80, right? So you can explore more this one. Yeah, this is not difficult because of all the things that you can click and see. So you can try. If that is a if mistake, then you just back again. Yeah, then try the different things, right? So that is for the financial. Yeah, this is sum. This is the lookup. Yeah, more if you need more function. Yeah, statistic here. See, average. Yeah. Yeah, this is function. If you can also write the function, yeah, by using the function. Yeah, so deviation, yeah, distribution, yeah. So many mean, median, yeah, max, yeah. So you can find this one, yeah, from the statistical function here. Yeah, permutation, yeah, skew, yeah, t-test, so many things. So can you see the same? Yeah, as I see here in Excel.
Yes.
Same, right? Because sometimes the feature is not available. Maybe you need to install the function add-ins, yeah, add-ins from the Excel. Yeah, sometimes if you do not, if it doesn't appear like this, then you need to install the the add-in here, yeah, option. Yeah, and then there is the formulas, for example. Yeah, so then you can select which kind of formula that you want to put. Yeah, and general, yeah. Yeah, so that is add-ins here. Yeah, so for example, you put the analysis tool pack here. Yeah, tool pack here. Yeah, so in add-ins and okay, then it will appear the analysis tool pack here. Yeah, in data analysis, right? So here, yeah, in data, there will be data analysis when you put the data analysis tool pack for add-ins. Yeah. Can you see?
Yes.
Try to see. Is there any data analysis in your Excel here? The corner side, the up side, I mean the right side of upper right side, data analysis tool. Can you see? Please check in your Excel. Check the data analysis. Is there tools for financial and scientific data analysis here? As you see my cursor here, yeah, data analysis tool. Yeah, from data, yeah, file, home, insert, draw, page layout, formulas, data, yeah. Review view, then from the data, you click the data, and it will appear some this one function, yeah, or buttons here, and then you find the data analysis part here. the right side, yeah, upper right side. And there is some also the forecast sheet, yeah, what if analysis, yeah. Yeah, for scenario manager, goal seek, yeah, data table. Yeah. Later on, we will learn about this. Okay, so this is the basic one. So we continue with the descriptive. Later on, we explore more. Yeah, and the tutorial. So we continue on the theoretical first. Yeah, the slide. Yeah, so the most important thing that you have Excel right now. Yeah, so we start to learn Excel, and after that we'll introduce about the SPSS. SPSS actually also very useful, especially for the data analytic if you want to perform analysis, yeah, especially for the final project, yeah, or graduation project, yeah, or any project in any module, yeah, that you have. If you need to perform the statistical analytic, yeah, or descriptive statistic, then you can use also the SPSS, yeah. Because in SPSS also some advanced tools, yeah, available, yeah, like neural network, yeah, Bayesian, or even the decision tree, for to perform more advanced tools. Yeah, so this is just the normal statistic, yeah, for analytic, or descriptive analytic. All right. So can you see the slide?
Yes, sir.
Yes, sir.
Okay, good. So we continue. Yeah, the average. So we got the average, right? So very easy still. Yeah. And then this is a frequency distribution. Then now you try this one. Yeah. This is also not difficult. Yeah. So enter this value. Yeah, with the Excel. Yeah. Now you open the Excel, right? Can you open the Excel?
Yes.
Yeah, so then you just write down this one, the value, yeah, here, the left column here, because this is the value. This is the value. Yeah, this is the frequency distribution of the for the IQ for a class. This is the total. Yeah, so yeah, here until 162, and this is the frequency. So you should write this frequency based on the appearance. Yeah, actually based on the what's it, the frequencies, how many appear this number, yeah. So 82 1, yeah, this is just example. This is 93 2, yeah, 1312, yeah, all are 1, yeah, the others. So means that 131 appear 2, yeah, two student have the same IQ 131, yeah, right. So this one, yeah, two students have the same IQ 93, yeah, because so it appeared 2 times, yeah, in frequency. If 1 means that only appear 1. Okay. So we will get this one, yeah, this is the percentage, because so actually 1/24, yeah, this one, yeah, to get the percentage, yeah. So you can use Excel, very easy to do this, yeah. Yeah, I mean the basic one. Yeah, you can explore. Yeah, no worries. Yeah, if you made the mistake, then just try again with difference. Just undo, and again you try again. Yeah, you try with a different formula. Yeah, available on Excel. Because all this is the learning process. Yeah, study. Don't worry to make the mistake. If you make a mistake, that is fine. Then just back and again try with different formula, right? Yeah, because it's the learning process. Yeah, no problem. Then you can, understand. Yeah, okay, this tool is the function for example, to find the frequency, to find the sum, yeah, to find the average. Yeah, minimum, maximum, yeah, data analysis or data analytic. Yeah. So 1/24. Yes. So this is the percent. Yeah. This number is actually from, because of the frequency is 1. Yeah. The total is 24. Right. So the percentage of the frequency will be 1/24. Right. So based on this, you will get 0.04016. Yeah, we can say 42. So 0.042, because this is percent, yeah, it is 100%. So you need this one need to times 100%. So you will get 1 to 4.2. So if the frequency is 1, so you will get the, yeah, is the frequency 1, the percentage will be 4.2, right? Yeah, because so 1 out of 24, yeah, this is the total is 24. 1 out of 24, yeah, is 0.042 times 100%. 100% because this is percent, right? So we'll get 4.2. Yeah, this is only one frequency. How about if two frequency, 2 times? So means that like 4.16, yeah, times 2. So you will get 8.3. Yeah, 332. Right? So 8.3. This is 8.3. Yeah, because this actual value is 0.0416. Right? So we make it round to be 0.042, yeah, or 4.2. So then when we have 2 frequency, yeah, so then it will be, yeah, times 2 this one, yeah, or you can easily this one from where it's actually 2/24, yeah, divided by 24. So how much this one? So also I use the calculator to count this one. 2/24. So you will get 0.083. So in order to convert to percentage, yeah, so times 100%. So you will get 8.3. Yeah, here. Okay. Understand?
Yes, sir.
Yes, sir.
Yes, good. Oh, still online class. All right, so this is still basic, yeah. So the cumulative percentage, yeah, cumulative percent. So the first one, yeah, this one, yeah, yeah, from this, yeah. So second one, yeah, of course, you just 44.2 plus, actually, because this one actually not 4.2, 4.16, right? So then you will get 8.3. So 8.3, yeah, plus, yeah, 4.2, you get this one. 12.5, yeah, plus 8.3, you will get this one. 20.8 plus 4.2, you will get this one. 25 plus 4.2, you will get this one. 29.2 plus 44.2, you will get 33.3. It's all until the final one. 95.8 plus 4.2, you will get 100. So finish. Yeah, 100 is cumulative. Yeah, so supposed to be 100 percent for the percentage. Yeah, right. So this one all. Yeah, this one. Yeah, plus this. So you will get this. 1 plus this, you will get this. Right. All this one. 41.7 plus 2, you will get again this one. 45.8 plus 4.2, you will get 50. Yeah, until finish. Yeah, until 95.8 plus 4.2, you will get 100. Yeah. But then with Excel, this will be very easy. Yeah, I mean, just use the formula. Yeah, on the Excel. Yeah. From the formulas, find the cumulative percent, find the percent, yeah. But you have this data, yeah, value, the data, yeah, the number, yeah, with the frequency. So then after that, you can count the others, right? And then group relative frequency distribution, yeah, this one. So you make the range, yeah, based on the data given, yeah, from the IQ for 2 classes. So we combine the data for IQ data for the 2 classes, yeah. So then we make the range, yeah, for this. Yeah, for example, the first range, yeah, because we have the minimum 80, yeah. And then the maximum one is the max, yeah. We have the max 162, I think, right? Yeah, from these two classes, yeah, we have the minimum 80, right? So based on the Excel as shown you before, yeah, 80, and then the maximum is 162. I think that is, yeah, because so in class A only 89 the minimum, so we use 80 from the class B, and also the maximum 162, yeah, in class B. In class A only 140, so the maximum 162. So we create the range based on this, yeah. For example, we create the range from 80 at the first range to 89, yeah, from 90 to 99, yeah, from 100 to 109, 110 to 119, the 20 to 129, 130 to 139, 140 to 149, yeah, 150 and over. So you check the frequency, yeah. So the range from 80 to 89, how many here? 80 to 89. So 80 itself, yeah, and then 87 and 89. 3, all right? How many? From 80 to 89 in the range, this one from this data. How many number here?
3.
3, yes. What is that? What is that, Akil? You said 3.
80, 87, and 89, sir.
Yes, great. Yeah, that is the number which is in the range of 80 to 89. Right, so 3 numbers, 80, 87, and 89. So that's why we put here 3 frequency, because so it 3 times appear, yeah, for that range. Right. Yeah, and then from 90 to 99. Yeah, how many here? From 90 to 99. How many number appear? The range from 90 to 99. Always, I don't know why it appear line like this. 90 to 99. So which number? 93, right? There is a 293. And then 96, right? So 93, 93, from 90 to 99. 93, 93, and then which number? In the range of this? 96, right? Any other number? The range of
Yeah.
90. Yes,
97 and 98, sir.
yes, very good. Yes, exactly. So this is the number 97, 98. Is there any other numbers in the range of the within 90 to 99? No, right? Finish.
Yes.
Okay. So we have 1, 2, 3, 4, 5. 5 here. So we have 5, right? Okay. Eight, 14 plus 20. Okay. All right. So again, we check the next range. 100 to 109. Yeah. So 100 to 109. 100 to the 109. So what is the number? The range of 100 to 109? Just yes, state here 100 to 109. Is there any 100 here? No, right? 101? No.
No.
Yeah. So 102, I think, isn't it? 102, right?
Yes. Yes.
102. And then 102 only one, right? And 103. How many 103? Only one.
One.
Yes. And then 104 is there?
No.
No, yes. 105?
Yes.
Yeah. And then see 106 is there? Yes. Yeah.
Yes.
Only one, right? Yes. Okay. 107 is there?
No.
No. And 108? No?
No. No, sir.
Oh. 109, 108,
Two.
no. 109. 109, how many?
209.
109,
Two.
two. Yes. Right? Okay. So we have how many? This one? How many number in the range of 100 to 109?
6.
6. Yes. Good. So this is 6. Yeah. So you just follow this method. But by using Excel, it is very easy because you use the analytical, yeah, as I saw you before. So you just use the analytic, yeah. This is the one. Yeah, with the analytic, yeah, we can get all the things. Yeah. So this is the formula. Yeah. And this is the data. That one. If you have the data, then you want to perform any data analytic. Yeah. Yeah. Forecast sheet formulas. Yeah. Calculation option. Logical is a sum, more function if you want. Yeah, see, it's for logical. Yeah, or you can find data analysis. For example, for descriptive statistic. Yeah, so we enter or the summary of statistic, confidence level, for example, if we want. If not, then we can just untick this one. Yeah. And then we enter this one, yeah, from input range, yeah, the column, because this is column, right? This is column, so we input this one. Yeah, so you just see there is a number here, so you put here and you drag this one to bottom. And don't do all, yeah, because this is the average, and from the line highlight, what's it, the yellow highlight, you do not offer this one, yeah, until only 13, yeah, from 102, 97, and 127, 105. Yeah, this one, enter. Okay. Yeah. Then, yeah, this one, then okay. Yeah, then you got this one, the result. This is the result. Yeah, for the statistic, yeah, for the analytic here. Yeah, so based on this, you can see the mean, yeah, standard deviation, yeah, all the information about the statistic. Standard error. Yeah, sorry, this is standard error. A mode, yeah, mode for the first data is not available. Yeah, for the second data, the mode is 109. Yeah, maximum range, this is range, yeah. Yeah, from the maximum minus the minimum. Yeah, the range is from maximum here 140. Yeah, this is the first, the class A. Yeah, class A. This is class A, and the second one is class B. Yeah, count 12. Yeah, yeah, count 12, and then the largest is this one. Yeah, 140, and then the smallest is 89. This one also the same. The sum is this one. Is the sum. Yeah. Yeah, sample variance. Yeah, standard deviation is this. Yeah, you get standard deviation, this one. Yeah, so later we will study theoretically how to calculate this. Right, but this is the total for data analytic. Did you get this one? I just want to make sure that you get this calculation.
Yes, sir.
You got it?
Yes.
Yeah, good. Very good. Because this is very important. Yeah, this is using the data analysis. Yeah, so then in this case, this is summary of the all. Yeah, but then you can perform one by one actually. Yeah. So using the formula, yeah, or so check. This is for the stock. Get data. Short, even short, you can perform also. Yeah, so this is the student IQ data. And then yeah, this is the function, yeah, for all. And then for this logical function, math and trigonometry, more function. And this is statistic function. Yeah, for example, yeah, you can find this one. Is there any mean, median? And this median, yeah. So we put here, okay. And then until, yeah, let's say until this one. Okay. Oh, we need to put all, yeah. We can put all. Yeah, one by one, I think. Yeah, we put all. Then you can get the median. Yeah. One by one. Yeah, all. Yeah, or you can put this one until this one. Yeah. Right. Then enter. Then yeah, this is the median, 109. Yeah, so the result, yeah. So we check from the sheet. Yeah, 109, 109.5, right? So because of this is we make it you know, we right, so this is more number. So the median, yeah. So you just use the formulas, yeah, here, and statistic, using statistic. Can you see the was it this one, my Excel over there?
Yes.
Okay.
Yes, sir.
So can you see the moving, the movement of the cursor, right? When I show
Yes.
you, okay, so good. Yeah, because of yeah, otherwise then yeah, difficult to explain. Yeah, if you cannot see this one. All right. So this is the statistic. So which one you need to perform? Yeah, was it the process? Yeah, the analytical statistic. Yeah, average. Yeah, this one binomial. Yeah, it is many. And I show you the very good books. Yeah, to learn. Yeah, about this Excel. Yeah, because of later on you should use this Excel, yeah, for many things, yeah, many analytical data and analytic, right? So I will show you the book. Yeah. Yeah, this is the book. Can you see PDF file, the book?
Yes, sir.
Okay, good. This is very good book. Yeah. you can download from the internet. Yeah, maybe from UTP also. UTP maybe have this book also. Alright, so Microsoft Excel, data analysis and business modeling. This is the latest one, yeah, Office 2021, and with also Microsoft 365. Yeah, so then you can use this book is advanced because of all details you can find in this book. Yeah, how to perform the calculation, the data analytic. Yeah, here. So the page is until more than 1,000 pages. So you just see the content, content here. So which part that you want to perform, which one? Just click, click which one that you want to perform. Calculating optimum bid, this one in detail, so you can see index match function, more financial time and time function, three-dimensional formulas, sensitivity analysis, scenario manager, sorting, validating data, basic charting, moving average, random variables, solver forecasting, even the traveling salesperson problem also available. Viewing, analyze pattern of data, sensitivity. You can find this book from internet or from library. Try to find right now this book and try to learn. This is a lookup function, and then if you need to see in detail, for example, so then you just click this one. This answer, the answer. Okay. From the first content like this. So pricing, the term calculation or optimum penalties. Is for ANOVA, multiple regression, charting, data model. This one for data with descriptive statistics. So you can see here. So just click this one. So then you can see the summarizing data with descriptive statistic. So then you can learn from this one. See there. So click the data tab in the analysis group, click data analysis. Dialog box will appear like this. And descriptive statistic on click OK. After you highlight which part of the input range, here, as I shown on the Excel before, you just highlight which range that you want to insert, or to be an input of this descriptive statistic. And then after that, you click which one that you want to output to see. Summary statistic, for example, just click summary statistic. Here, choose in the input range box, and select the column option, if available, output range. And after that, select summary statistic and click OK. So then you will get this one, the mean, standard error, mode, standard deviation, sample variance, yeah, all. So it is the meaning of each, yeah, is mean. How to calculate mode, right? Yeah, so this is how to calculate. So this is from this book. And then from Advanced with Excel formula, also there is a good book, yeah. But this is the old one, yeah, not the latest version, but yeah, still you can use. This is the dictionary, yeah. Function dictionary actually. So then you can see function dictionary here. So I will show you. There is also the dictionary, a dictionary of Excel. So then you can see the function dictionary for each. And this is the function dictionary. Yeah. For example, you want to see the statistical. These are the statistical. Yeah. So average, yeah, correlation, count, yeah, forecast, yeah, frequency. So you want to find the frequency here on based on the given data. So then you just provide the function for frequency. Yeah, so this is the each explanation, yeah, from formatting until until finish, yeah, because of many things. Yeah, this analysis tool part, yeah, that I mentioned, yeah. So then you need to add in the file containing of analysis tool pack here, yeah, in order to provide many analytic or analysis tool, yeah, in your Excel, right? Because sometimes it is not included, yeah, by default. So you need to add in. Yeah, actually it is free. Yeah, so add in on the Excel. So then after that you will see the function, yeah, for mathematical or statistical. Yeah, right. Okay. So can you see the slide? Can you see the slide?
Yes, sir.
Okay. So then after break, then you explore this whole thing. Yeah, I will continue to explain. I mean, before end of the session. Yeah, so perform some was it the this one? Yeah, I mean the exercise. Yeah, for just to be familiar with Excel. Yeah, just explore. Yeah, then yeah, try to perform some processes like here. Yeah, to find was it the percentage, the frequency given. Yeah, 80, 89, or you can just put the data. Yeah, raw data. Then after that you can find the frequency, the percentage. Yeah, because so this is the raw data. Yeah, raw data here. Yeah, or this one also for practical thing. Yeah, it doesn't matter. Yeah, which one do you want to do? Yeah, this one. Yeah, this is the raw data. Yeah. Yeah. So then after based on this, then we can do many things actually. Yeah, it's just for example, yeah, with a small amount of data. So based on this, we can provide the visualization, yeah, using the graph, yeah. This is the first one, yeah, histogram, for example. So used to present the frequency or relative frequency, yeah, of an ordinal, interval, or ratio level of data, yeah. Most often used with the ratio or interval, yeah, for R or I data. Right, so this is the score. Yeah, you can see the score. Yeah, the coordinate x coordinate here. Yeah, horizontal. So the score, and the vertical one here is the number of the student. How many students with got this score, right? So, for example, 20. Yeah, you can see this final score. So the mark, yeah, here 20. How many? So one student. Yeah, 30, one student also. And 40, yeah, or we can say range also, 30 to 40, yeah, 20 to 31, yeah, 30 to 42, yeah, two students. 40 to 50, only one student. That's 50 to 60, two students. Yeah, 60 to 76 students. And 70 to 80, nine students. Yeah. Yeah. Based on the graph, based on this graph, then we can read 80 to 90, there is a 13 student. Yeah, and then 90 to 100, yeah, there is a 5 student. Right? Okay. So 30, this is a 5, this is a 9, this is 6, this is a 2, this is 1, this is 2, this is 1. Right? Yeah, so how many students in total? Yeah, because of this one, this is 5, so 5, 13 plus 13 plus 9 plus 6 plus 2 plus 1 plus 2 plus 1. These are the total student, the number of students in the class. Right, and then histogram, yeah, almost the same thing, yeah, the percentage and the year, yeah. And then this is the IQ histogram, yeah. So based on that, you can create the histogram actually, yeah, by using the Excel, yeah. By using the Excel, you can create the histogram, yeah. Actually, I got the one because based on that we can export, yeah, to the Word, Word format. The Word format. Okay, this is the result. After you extracting this one, yeah, then you will get. Can you see the screen? Yeah, descriptive. So based on the result, we can extract this one. Yeah. So this is the statistic data, yeah, for range. Yeah, the number of the student, range, and minimum, maximum, yeah, the mean, and deviation. So the descriptive statistic, yeah. So variance, skewness, yeah, kurtosis. Okay. So this is a histogram. Yeah. So summarizing numerical data. So measure of the central tendency for groups, middle values, like mean, median, mode, means, median, mode. So that these are we are going to learn, and measures of dispersion, variability, summary of differences, like so we will learn how to find the mean or average, median, and mode, and then measures of dispersion, how to find the range, interquartile range, variance, and standard deviation. Right? So did you learn this one before? Oh, I do not show. So hold on. Did you learn before this one? This maybe in other module. Do you learn before this topic? No?
Yes,
Yes. In what course?
secondary school, sir.
Yes. Yeah. In the school also you learn some of these practical things. I mean this theoretical and calculation, simple calculation. Correct. Yeah, because of these are actually the basic. Yeah. Basic for us to perform the data analysis or data analytic. The basic knowledge. Supposed to be not difficult, because of you have the basic knowledge, and this is just to remind, but with more complex data. That is the difference. So that the basic statistic, but now you have a more complex data if compared to the previous study. All right. So can you see slide?
Yes, sir.
All right. So the mean, the central tendency. The first one is mean. So most commonly called the average. Mean sometimes we call as average. So add up the values for each case and divide by the total number of cases. We have learned before. I showed you how to calculate. And your friend also answer the question. Try to calculate the mean, or the average. The same meaning. And then these are the formula actually using the statistical formula. You can see here. So y is your variable. This one y equal to y1 plus y2 plus yn divided by n. So how many number of the data? So sigma I to n yi. So that is the formula divided by n. So from y1, y2, and so on until yn divided by n. This is the formula. So you can see this is not difficult. As mentioned in the previous slide. So just if you have a 13 data, for example, you just plus add up all the data from the beginning until finish, and after that divided by how many number, how many data given, right? If 13, then divided by 13. If 12, divided by 12. If 1,000, divided by 1,000. But it is more, of course, difficult to calculate manually if the data is, let's say, more than 100. Start headache, because of complicated. That's why you need to perform the calculation for statistical, for descriptive analytic or a statistic. Then you need to use the tools, like Excel or SPSS. So then it will be, of course, very helpful. Otherwise, then you calculate one by one, then will create a problem. Because sometimes missing number or missing count and so on. All right, means, yeah. The mean is the balance point actually. So each person, yeah, score is like 1 pound placed at the score position on a seesaw, and you can see here the diagram, the figure, and the mean equals 110. The place on the seesaw where a fulcrum finds balance. Yeah, so you can see here, yeah, seesaw. Yeah, so 93. Yeah, this is yeah, cm, and this is the the distance, yeah, from the balance, and then 1 lb, and this is the head. So the mean equal this one, yeah. So from where, yeah, so you have to add all and then divide it by what, this one, by 3, all right? Because so this is 93 plus 106 plus, yeah, from where this one, 110, the mean, from where from where this one, yeah, I mean the value of 110. Can you count? From where? Yeah, this is from this one plus this one plus this one. 93 plus 106, the second one, and plus 131. Right? Yeah, this is about, yeah, 30, let's say, but divided by 3 and 110. Yeah. Right? So we got this one. This is the mean, right? The mean equals 110. So the place on seesaw where a fulcrum finds balance is here. So the scale is balanced because of here. Yeah, this is the balance. Yeah, we have to find. Yeah, this is balanced because of this is a 17 and 4. It's the same as 21. So 17 plus 4, yeah, equal to 71. So that's why this is balanced. Yeah. The same number here. All right, so means can be badly affected by outliers. Yeah, that is the thing. Data points with extreme values unlike the rest. Yeah, so outliers can make the mean a bad measure of central tendency or common experience. This is one example. Yeah, why the mean affected, yeah, badly affected, yeah, by outliers. Income in US, right? These are the common people here. Right, but there is a Bill Gates loan, yeah, which is the income is very, very high. So we can say this one is outlier. This is not the normal one. This is the normal here. So that's why with this part, yeah, it will affect to the mean. Yeah, then very bad. Yeah, because of the mean will count this one also. Then we will change to this part. Right, so not exactly in the middle of the common data, yeah, but tends to go to the skewed, yeah, the slope, yeah, slope of this one tend to go to the right side here. I mean, right, so outliers can make the mean a bad measure of central tendency or common experience. Yeah, that is the thing. Because of with one outlier, then it will affect to the mean. The mean will be more tends to the outlier. And that is the thing. All right, so the median, yeah, the middle value when a variable's value are ranked in order. So when we make a rank, yeah, in order, and the point that divides a distribution into 2 equal halves. So when the data are listed in order, the median is the point at which 50% of the cases are above 50% below it. So actually 50th percentile. So this one example, right? So class of A student, yeah, IQs with 13 student here from 89 to 140, right? So how to find the mean? You can get the mean, yeah, by 80 add up to 93, 97 and so until 140 and divided by 13. That is the mean. Then how about median? So we count the middle here, 6 cases above and 6 cases below. So 1, 2, 3, 4, 5, 6. Because this is the there is a 109, right? So this is exactly as the median. 110, 115 until 140. So 109 is exactly the median because there is a 6 cases and this one also 6. So this one is the median, right? Understand? So understand how to find the median?
Yes.
Yeah, it's easy, right? Yeah, so for the odd numbers is very easy because so we put just this one in the middle. We can find easily the median. But for the even number, even number is difficult. It's not difficult, but you have to make a different calculation. Not like this. Right. For example, this one. The first student were to drop. So this one remove. So then we have 93 until 140. So the median is between one, actually, because of this is 12. So there is this is 6. Another one is 6. So the median is in between 109 to 110. So how to count this? We have to add and divide it by 2. 109, the median, plus 1010 divided by 2. So we got the 109.5. So this is the median. If we excluded 89, so then the number will be even. So we have to count in the middle 2 numbers plus 2 numbers 109 plus 110, and after that divided by 2. So then we got this one, right? So this median. So the median is unaffected by outliers. So it doesn't affect the outliers. Is not affected. It is not affect to the median. This one, So making it a better measure, to find the median, better measure of central tendency, and better describing the type typical of a person than the mean when the data is skewed. For example, we'll get here outliers. Still the median are here. So not tend to the outlier here. Because of the mean we will put here. Tend to the outlier. All right. I think we stop here. We take a break for a while. About 1 hour. Then after that we will continue. If the first student in median, if the student were to drop out of the class, were withdrawn from the class, so that there would be a new median here. Because of this one, for example, number. I mean, with this value IQ, this value they withdrawn. One student here withdrawn, and then the remaining here. So it will be the new median. So I wrote the experience. Here, because of this is the even number. Even number. Previously odd number, then easy to find the median. Even number, so in between the median will be here because of top 6 and not the bottom. I mean the top and bottom, in between. So here there is a 2 number because in the middle exactly there is no number. So but then 2 numbers you have to add this number and divide it by 2 because there's 2 numbers. So these are the new median. So 6 cases above and 6 cases below, right? 6 numbers above, 6 numbers below. So the median is unaffected by outliers, in this case, so making it better measure of central tendency. So better describing the typical person than the mean when the data are skewed. So when data is like this, skewed, so then a median is better than mean, because of mean affected by the outliers. This is one example. The income, for all of us here around this, in general, but there is some people outside, outlier, Bill Gates, Mark Zuckerberg, Elon Musk. So these are categorized as outlier. So that's why then the median will, the graph here will skew like this, and then the median pause is here. So it's unaffected by outliers. Still, even outliers is here, exists here, but then unaffected. The median still almost in between. On the normal distribution. So this is the median, right? So if the recorded values for a variable from a symmetric distribution, for symmetric distribution here is a symmetric, symmetric distribution, exactly. So the median and mean are identical. So because of identical here, exactly in the center. If it is symmetric, so mean and median will be the same. But if skew, in skew like this, skew with data like this, diagram. So data mean lies, further towards to the skew than the median, right? So mean will go to the skew like this. This is the mean, right? Toward the skew, then toward the skew here, and median here. Median maintain almost still there, almost still like this. But mean, will affect it, by the skew, outlier in this case. That is the difference between median and mean. So the middle score or measurement in a set of rank score or measurement, the point that divides a distribution into two equal halves. That is the median. So data are listed in order, and the median is the point at which 50% of the cases are above and 50% are below. So this is the 50th. So the 50th percentile, for median. Right. So for mode, mode. So the most common data point is called the mode. So this is the highest frequency. It appear more than the others data. So the combined IQ scores for the classes, A and B here. Yes, the data given before, from 80 till 162. And then, the mode, we can count the frequency of each. How many times appear? So the mode will be the highest. The highest appear. From this data. So it means, in this case, it looks like 109 appear 3 times, right? So this one will be a mode, right? Of this mode of this data. There is any other 3 times appear? No, right? Only 109. I think only 109. 131 only 2 times. And then 93 also two times only. So the highest appearance here, the common data, the most common data is 109. So there is one mode here, which is 109. With 3 times appear frequency. However, it is possible to have more than one mode. More than one mode. For example, if this is we remove this one, so it will be 109 only 2 times, right? So this is first mode, for example, and we have a 101, 131 with 2 times. It is the second mode, and 93 2 times. This is the third mode. So we have a 3 modes. So this is fine. The mode can be nothing. None means that all the same. For example, appearance is 1. Same all, and there will maybe 2 modes. It is also okay, and it can be more than 1. One also fine. Like previously we have only 1. 109. 1 mode only, which is 109. 3 times appear frequency. And then if we remove 109 once, and then it has a 3 mode. 109, 131, and 93. So these are to find the central tendency for mode. Right, so the most common one. So it may not be at the center of a distribution. This can be because of the highest appearance. So maybe not in the center. So we can see here that the distribution below is bimodal. Bimodal, even statistic can be open-minded. So can see here. So this is the IQ. That's this count. So how many students? So we can see here, the range from 89 to 96, there is 2 students. Right. And then the range from 128 to 131. Sorry, 128 to 140. There is 2 students. So these are bimodal. So we have 2 mode. The first one mode and the second one mode. Right. The second one. So 2 mode. Right. So it may give you the most likely experience rather than the typical or central experience. And the symmetric distribution, the mean, median, and mode are the same. This is the thing. In symmetric distribution, mode, median, and mean are the same. Here, the symmetric distribution. The mode is the highest frequency here. And if this part, if in this situation, condition, median, mean, and mode will be the same in the same value here. So that is the mode. If the right skewed here, so then the mode will be on the highest here, still maintain. And mean, slightly come to this part. Sorry, median, and mean here. Mean will be affected by the skew, by the outlier. So then you can see the difference between all, between 3, this one. Mode, median, and also mean. Right. So measures of dispersion, after the mode, and then measures of dispersion, range, So we have how many deviation? I think until this part, and after that you can try. I will show you. I mean, you can use Excel to try for each. I will send you this slide, and then you have a time, just to practice, some part, and after that we have time maybe around 20 minutes, before we finish, then to present the tutorial too, just to share some idea, and after that finish, then finish for the lecture today. All right, so we go until this one, the range, the spread or the distance between the lowest and highest values of variable, So no robust, sensitive to extreme values. Yes, of course. If you want to find the range, yeah, for example, this class A IQs for 13 students, yeah, the lowest one 89, yeah, for class A, the highest one 140. So class A range will be the highest, yeah, 140 minus 89, 140 minus 89. So you will get the 51. This is the range, yeah, for class A IQs, yeah, 13 students. So for the class B, the range will be the lowest is 80, the highest is 162. So then range will be 162 minus 80. So the result is 82. So this is the range for A, class A, this is range for class B, right? So easy to get the range. Any question, any comment until this part? Yeah, please, if you have any comment or any question. I think still basic, yeah. So no, I mean, it is because of you have also knowledge, basic knowledge before during the secondary school. And yeah, this is the common thing, yeah, to find average, yeah, mean, and mean, yeah, average or mean, and also median, yeah, mode, so easy to understand. And this is the range, yeah, for the measure for this dispersion. Yeah, so then you can easily find. So we continue to measures of dispersion in interquartile range. Yeah. So quartile is the value that marks one of the division that breaks a series of value into 4 equal parts. So quartile, yeah, quartile we break into 4 equal parts, right? So for example, this is from 0 to 100. So quartile we have to break this from 0 to 100 to be 4. So first we divide it into 2. Yeah, so this is a half, yeah, 50. And then each we have to divide it into 2. Yeah, so 0 to 50 is 25. Yeah, and then another one, 50 to 100 is 75. Right, so 50 to 100, 50 divided by 2, 25 plus 50. So these are the quartile, right? So this is the 25% first, second 25%, and then third 25%, and then fourth 25%. Right? So there is a 100% for 25% each. So 25th percentile or Q1, we say, yeah, here we say Q1. This is a Q2. This is a Q3. This is a Q4. Right? Oh. Now we disappear the line. I don't know why. Okay. It's 25. Yeah, Q4. Right. So 25th percentile or Q1 divides the first this one, yeah, 25. This is for the Q1 percentile. Yeah, so the first quarter here. Yeah. The first quarter, yeah, of cases from the letter, yeah, from the letter this one, yeah, 3 quarters. So this is the first, yeah, and then for 75th percentile or Q3 divides the first 3 quarters of cases, yeah, from the latter quarter, this one, right? So this is the Q4, yeah, Q3, Q1, Q2, Q1. Right, so the interquartile range, yeah, or IQR is the distance or range between the 25th percentile and the 75th percentile. So from Q3 to Q1. So that is the interquartile range. So we can see here. So IQR is usually more robust than the range. So this is 20% of case. Yeah, for example, this is from 0 to 1,000. Right, so we divide it into 4. So in the middle, yeah, the median is 500, and then in between of 500 to 1,000, this is 75, 750, and this is 250. Yeah, so this one each will be 25%. Yeah, for quartile. So Q1, Q2, Q3, Q4. Right. So a measure of the spread of the recorded values on a variable. Yeah, a measure of dispersion. So a larger the variance, the farther the individual cases are from the mean. Here the mean. Yeah, if the larger variance, so it will be far away from the mean. Yeah, for individual cases. Smaller the variance, the closer the individual scores are to mean. Yeah, this is the mean. So it will be closer. Yeah, if the small variance. Right. So that is the thing. Yeah. Yeah, for the measures of dispersion. Any question or any comment? Yeah. So I think we stop until this part. Yeah, we'll continue the other one, but I will send you first this one. Yeah, and then you try some part here. Yeah, with the Excel. Yeah, just to be familiar with Excel. Yeah, there is a. You just try. Try this one. Yeah, try this Excel with Excel. Yeah, and yeah. Try this with Excel, all right? And this is page number 6. And then page number 7. Yeah. And then page number 8. Now we try. I will write down. Yeah, slide number, based on the slide. Number 6, 7, 8. Yeah, and then this is histogram. Yeah. Slide number 11. Just to confirm that is the right one. Yeah. And page number 25. Yeah, slide number 25. Yeah, that is five Excel that you can try. Yeah, here. And to be familiar, with this Excel, because of later we have more calculation and then more practical with Excel. So that's why I try to be familiar first. Yeah, and then try to download the book. Yeah, because the book is available online that I shown you with 1,000 pages more. So then you just click which one that you want to know. Yeah, like a catalog, and you can see also one by one. Right, I will share this. I will send by email. Yeah, this slide for.